Okay, let's jump right into this explainer. We are going to do something pretty incredible today. We're going to take the absolutely unimaginable 4.5 billion-year history of our planet and compress the whole shebang into a single intuitive 24-hour clock. Seriously, if you're a biology student, or really anyone who's ever struggled to wrap your head around exactly how long it took for simple single cells to evolve into, well, us, this is for you. We're going to watch a chaotic cloud of stardust turn into a bustling living world, ticking by hour, minute by minute. Let's get into it. So here's our roadmap for the day. 1. Dawn of the planet. 2. The single-celled morning. 3. Afternoon explosions of life. 4. The evening land rush. 5. Dinosaurs and the asteroid. And finally, 6. Humanity's final minute. Starting with Section 1, Dawn of the planet, midnight to early morning. All right, we start our clock exactly at midnight. The Earth has just formed, and it is a brutal place. We're talking blazing fast 6-hour days and just constant, violent cosmic bombardment. It's basically a war zone. At just 40 minutes past midnight, a Mars-sized planet named Theia slams into Earth at a devastating angle. It completely disintegrates, and that molten debris clumps together in orbit to actually form our moon. Fast forward a bit to 1:15 in the morning, Earth finally cools down just enough for water vapor to condense. We get our very first oceans, though, you wouldn't want to swim in them. They're practically boiling, sitting anywhere from 40 to 85 degrees Celsius. And then, at 1:52 a.m., down deep where hot volcanic streams meet this early chaotic ocean under immense pressure, we hit our first real biological breakthrough. The synthesis of the very first organic molecules, things like amino acids and RNA. The raw building blocks of life are officially on the board. Moving on to Section 2, the single-celled morning, the wait for complexity. So by 4:30 a.m., the very first fully formed cell exists. But evolution is about to face some massive hurdles as the morning drags on. Around 11:13 a.m., these primitive single-celled organisms, specifically cyanobacteria, pull off a neat trick. They figure out how to use sunlight to make food, photosynthesis. But there's a huge catch here. You see, oxygen wasn't originally this great life-giving gas. At 11:35 a.m., the great oxygenation event hits. These bacteria are pumping out so much oxygen that it builds up as free gas. And for most living things on Earth at that time, it was a deadly poison. It was a literal climate crisis, forcing early life to either figure out how to adapt to this toxic new atmosphere or just completely die out. But life is resilient, right? The ones that did adopt pulled off something absolutely extraordinary. This is foundational biology right here. At 1339, so about 1:40 in the afternoon, one cell completely engulfs another. But instead of digesting it for lunch, the engulfed cell just sticks around. It adapts. It actually starts performing useful functions for its new host. This is an endosymbiotic union. It's two cells teaming up permanently to unlock entirely new levels of energy, and in the process, creating a brand new, highly upgraded type of cell, the eukaryote. To really visualize the leap that just happened, think of it using an architectural analogy. The early cell, the prokaryote, is basically a simple studio apartment. Every single cellular component is just jumbled together in one open room. But this new cell, the eukaryote, that is a large, highly organized house with separate rooms. It's got a dedicated nucleus specifically for safely storing genetic info, and it's got mitochondria acting as its own built-in power station. Honestly, this structural leap is the exact thing that makes complex life, everything from a mushroom to a human being, biologically possible. Which brings us to Section 3, Afternoon Explosions of Life, Multicellular Diversity. As we cruise into the afternoon, our newly complex eukaryotic cells start clustering together to form primitive multicellular life around 3:43 p.m. But they have to survive a literal frozen wasteland before they can really thrive. At 2038, so pushing 8:40 at night, the climate violently shifts again. We hit snowball Earth. Imagine the entire planet covered in ice several miles thick, with temperatures dropping to a staggering -50 degrees Celsius. Most life just gets wiped out. But, incredibly, some life hangs on in hot springs and cracks in the ice. And the payoff is huge. By 9:02 p.m., massive volcanic activity has melted the ice, triggering the Avalon explosion. This is a massive sudden emergence of all these weird, soft-bodied, radially symmetrical creatures just taking over the newly warmed oceans. And just 10 minutes later on our clock, at 9:12 p.m., the famous Cambrian explosion kicks off.
What you really need to take away from this is that this era was biology's massive R&D phase. Being soft-bodied just wasn't cutting it anymore. Nature starts experimenting wildly. We're talking hard body parts, armored plates, primitive spines. Suddenly, the seas are swarming with heavily armored trilobites and creatures like Pikaia, which actually had a primitive spine, making it the great-granddaddy of all vertebrates.
Section 4. The evening land rush leaving the ocean. Okay, so the oceans are now absolutely packed with armored fish and early sharks. It's crowded. So life finally looks toward the barren rock of dry land. And what happens next is just a beautiful domino effect. At 9:34 p.m., simple moss-like plants cling to the rock, stabilizing the dirt and pumping out oxygen. 6 minutes later, at 9:40, the bugs show up. Ancestral insects and spiders follow those plants, looking for a meal. Well, now the land is an all-you-can-eat buffet, so by 9:50 p.m., lobe-fin fish like tiktaalik start using their chunky fins to push out of the shallow waters. By 10:05 p.m., amphibians have evolved primitive limbs from those fins to hunt on land, though they're still tied to the water to lay eggs. But finally, at 10:20 p.m., reptiles develop the biological upgrades needed, like shelled eggs, to become totally independent of water. The land has officially been conquered. This leads us to Section 5. Dinosaurs and the asteroid, a reign cut short. The continents are smashing together to form the supercontinent Pangaea, and the interior gets bone dry. In this harsh landscape, at 10:48 p.m., the very first dinosaurs step onto the scene. Now, why did dinosaurs become so dominant? The critical detail here is their posture. While other reptiles sprawled out with their legs to the sides, think of a crocodile, dinosaurs evolved an upright stance with their legs directly underneath their bodies. This seemingly minor mechanical shift was a total game changer. It gave them incredible speed and agility, letting them utterly dominate the planet and evolve into towering predators, massive herbivores, and eventually the feathered ancestors of modern birds. But their reign comes to a sudden, brutal end. At exactly 11:39 p.m. on our clock, a 6-mile-wide asteroid, traveling at 12 miles per second, slams into the Earth. The sheer force of the impact vaporizes everything for thousands of miles. A colossal cloud of dust goes up, literally blocking out the sun and completely halting photosynthesis. In the catastrophic global winter and famine that follows, 75% of all living species, including every single non-avian dinosaur, are wiped out forever. It's an absolute tragedy, but biologically speaking, it's also a complete global reset. With the giant reptiles gone, the door is kicked wide open for small, warm-blooded, furry mammals, who had just been hiding in the shadows trying not to get stepped on, to suddenly thrive and take over all those newly opened ecological niches. Which naturally makes us wonder, on this 24-hour clock of Earth's history, when exactly do we humans show up? And that brings us to Section 6, humanity's final minute, the last 60 seconds. Brace yourselves, because everything you have ever known about human existence is about to happen in the literal blink of an eye. Evolution hits fast forward here. At 11:40 p.m., the first primates, basically tiny lemurs, are scurrying around in the trees. But by 11:58 p.m., just 2 minutes to midnight, climate shifts turn dense African forests into wide open savannas. Our primate ancestors are forced out of the trees and onto the ground, adapting to walk on 2 legs. This is huge because it frees up their hands to manipulate objects, driving brain development. And at exactly 23 hours, 59 minutes, and 13 seconds, Homo habilis, the handyman, emerges with a noticeably bigger brain and primitive stone tools. Now we're literally counting down the seconds to midnight. At the 24th second of this very last minute, Homo erectus fully masters bipedalism, learns to control fire, and starts leaving Africa. At the 48th second, Homo heidelbergensis is building shelters and using collective planning to take down massive Ice Age mammoths with spears. Our ancestors' brain volumes are just exploding right now. And finally, at the 54th second of the last minute of the day, Homo sapiens, us, officially arrives, coexisting for a brief, fleeting moment with Neanderthals. At the 58th second, we literally walk across the globe. And then, in just the final milliseconds before the clock strikes midnight, everything changes. The Neolithic revolution happens. We invent agriculture. At the 95th millisecond, we build the pyramids of Giza. Moments later, the steam engine is invented. 5 milliseconds after that, the internet is born. It is absolutely staggering to pause and realize that all of recorded human history, every empire, every war, every piece of art, everything you've ever studied in social studies, happens in a literal fraction of a second at the very end of the day. As we wrap up this explainer, I really want that sense of scale to sink in for you. We started with boiling oceans and toxic atmospheres. We figured out how to build complex eukaryotic cells, survived freezing over during snowball Earth, and outlived the dinosaurs, all to arrive in the final frantic milliseconds of a single day. If 4.5 billion years of relentless struggle and evolution brought us right to this exact moment, I want you to ask yourself, what in the world will our species achieve in the very next second?